So what we're going to talk about today is graphing ln and then the natural base. So remember that e to the x and ln of x are inverses of each other, right? Yes, we remember that. If you don't remember that, that's a thing. Okay? So we're going to talk about transformations. So I hope you have a calculator in front of you. If you don't, you need to get one because it's going to be beneficial today. So the first thing that I want you to do is make sure that your calculator is completely cleared. Okay, and we're going to graph ln of x. So we're going to hit second. Oh, no, I'm sorry. We're going to hit ln of x. Right. ln of x. Okay? That is the parent function. That's the OG for all this mess. Okay?
What about the negative?
We're not there yet. Okay, so when we graph, this is what our parent function looks like. So when we do all of our comparisons, because that's what transformations really are, they're really just comparisons of the parent function, this is what we're going to compare it to. Okay? So we're going to go back to that y equals button. We're going to scroll down to that y2, and we're going to type this function right here. So we're going to say ln of x minus 4. Okay? We're going to type ln of x minus 4. Okay? And when you hit graph, what are you going to notice? It's similar, but what happened? It moved over 4 units, right? Okay? So, what we're going to say for our transformation is it moved right 4 units. Okay? Then we're going to go back into our graphing calculator on the next one. And we're going to type that one in. So we're going to say negative ln of x. Notice how there's no parentheses around this whole thing. So we're going to put parentheses around just the x minus 3. So here it is again. Notice how there's no parentheses written here. We're going to put parentheses around just the x because this is really saying negative ln of x minus 3. Okay? When you hit graph, there's the parent function, and then here's the other one. So what happened? Okay.
Wait, it says quit. It says error.
Okay, y'all told me that it flipped. That's really called a reflection across x-axis. Okay? Now this minus 3 right here, that minus 3 means that we shifted down 3 units. Okay, so we went down 3 units. With me so far?
Yes.
All right, on the third one, we're going to go back into our y equals. We're going to clear that second equation. And we're going to type ln of x plus 7 plus 4. And we're going to hit graph. Okay? So what happened between the OG and the new graph? It moved to the left 7 units. Left 7. And then we went up 4. So we're going to go in and we're going to say ln of x plus 2. And then we're going to put parentheses around the whole thing.
Yes, sir.
And then we're going to hit graph. And we're going to notice that it goes to the left 2 units. Okay? When we graph this, I don't care how you graph this, as long as you pick the right graph, because you'll never be asked to actually graph it. So the graph's going to look something like that. Okay? And if you want to put the parent function on there, that's totally fine as well. Go ahead and try number 2. This without graphing. So look at this. It has a negative out front, so that's going to be a reflection across the x-axis. And then you've got this plus 4, so that's going to be up 4 units. Okay? We're going to see that, do you notice how, like, there's no parentheses around anything? So then there's just a parentheses around this x. So that means that this is going to be an up 4 or up 3 shift. Okay, if you don't believe me, then you can go into your calculator and you can type the OG function, which is ln of x, and then you can type ln of x plus 3 and hit graph.
What?
When you hit graph, look how it's up 3 units. Boom. Okay.
Wait.
Yeah. Okay.
So how is? Can you go back to the?
And if you were like, how is it 3? Look at it. It went from 0 to a 3. In the
X
table.
is supposed to be in the parentheses plus 3.
Yep. All right, so on number 4, my transformation is going to be right 3, down 5. And that graph is going to look like, so it's always the opposite inside the parentheses, so that's why it's right 3 instead of left 3. Okay? Good. So on number 1, you should have gotten a shift to the left,
9. Yes.
9,
Okay. Down.
and down 2. On number 2, you should have gotten a reflection across the x-axis, and then left 2 or left 1. And then the last one, you should have gotten down 3.
Yeah. Look at me.
Okay. So we've talked about natural log. So now we're going to talk about base E. So E is actually a number. It's 2.71 roughly. It's kind of like pi. So what we're going to do is kind of revisit some old stuff. So we're going to simplify these expressions. So right here, where it says e to the 6 times e to the 4th, that's kind of like when we were saying x to the 6 times x to the 4th. If we did that and we tried to simplify it, it would get us x to the 10th, right? Yes. So we would add those exponents. So we're going to do the same thing for this one. That's going to give us e to the 10th power. Okay? On number 2, same thing. We're going to have e to the 9th power. That's 27. On number 3, we've got, let's look at our numbers first. 21 divided by 7 gives us 3. Then we're going to use the quotient rule. So the quotient rule says that if we have the same base, we can subtract the exponents if they're being divided. So we're going to have 8 minus 2, which is going to give us e to the 6th power. So 18 divided by 3 is going to give us 6. And then when we take e to the 10th divided by e to the 5th, that's going to give us e to the 5th power. Now number 5 freaks y'all out a bunch. Let's look at it. 4 times 7, that's going to give us 28, right?
Right.
And we just talked about how we're going to add our exponents if we have the same base, right?
Right.
So what's negative 5 plus 8? 3. So this is going to be e to the 3rd power.
But they don't have.
Okay? On number 6, I've got negative 2 to the 3rd power. That's like saying negative 2 times negative 2 times negative 2. When I multiply that out, I'm going to get negative 8. E to the x raised to the 3rd power, that's going to be e to the 3x. So when you plug these in, you're going to get something along the lines of 403.35-ish. 43, something like that. Okay? Then if you plug in this one, what do you get?
0.5, 3.
If you plug this one in, what do you get?
1.5.
If you plug this one in, what do you get?
9.35. Are we not rounding?
I didn't tell you a specific rounding place. Alright, so for growth and decay on this one, a positive exponent is going to be growth. A negative exponent is going to be decay. Okay, and the reason why is because if you have a positive exponent, that's going to constantly increase. So we're going to increase a bunch. So that's going to be growth. Okay? Negative exponent means that we're going to decrease in our exponents. We're going to get smaller. So, on these next four, this first equation is going to be growth because there's a positive exponent. Next one's going to be decay because it has a negative out front. Next one, that's going to be growth, despite the fact that there's a negative in the very, very front. We're just looking at the exponents. And then the last one's going to be decay. Okay. So on this one, it has y equals e to the x. So this is like the OG or the parent function for like this group of functions. So if I graph this mess, I'm going to go into my y equals. I'm going to clear all this other mess out. And I'm going to hit second ln raised to the x power. When I graph that, it looks very, very familiar. Y'all used to do exponentials in Algebra 1. Okay? You just didn't use e. Okay? But this is actually what it looks like. So you've got this parent function that's like, yeah, boom. Okay? Again, I don't care what your graph looks like. Just give me a sketch. Okay? So what we're going to do now is we're going to graph this in comparison. So we're going to hit second ln minus x, close parentheses. We're going to hit graph. So what do you notice that happened between the first graph and the second graph? So it's a reflection across y-axis. And there's also a stretch of 2 because of this 2 out front.
Is this what?
So last one, we're going to go back into our graphing calculator. We're going to hit second ln. We're going to hit x. Make sure you put a closed parentheses on this one. Plus 3. You're going to hit graph. So what happened on this one? So it moved up, right? So it moved up 3. If you're unsure, just look at what this value is out here in comparison to the original. It's 3, right? We can also look at our table. At 0, 1 is where we started, and then we went to 0, 4. What's the difference between those? 3, right? No, yes, maybe. Okay.